Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to become engineers in the future. Then this video is interesting and important for their preparations in their engineering life in the future. And also, if you find the video important to your studies, please don't forget to subscribe. So this video is about finding the area of the circle given the lengths of the legs AC and CD of this right triangle where B is the center of this circle here. And I try to present at least four solutions in this problem. So AC is 25 meters, CD is 15 meters. So given the circle and given this figure and B as the center of the circle, AC is 25 meters and CD is 15 meters long. So I'll present four solutions. This is the first approach. So AC is given 25 and CD is equal to 15 meters. Therefore, if we denote the radius of the circle, which is AB, because B is the center, as R, the area of the circle is pi r square. So after we know R, then we can compute the area of the circle from area of circle pi r square. So I'll present four solutions to solve for R. Then in the final part, we compute the area of the circle after computing the radius in four ways. So if you denote this by R, then BC would be 25 meters minus R. Then since B is the center of the circle, if we connect points B and D with a straight line, the length of that line is also equal to the radius of the circle R. So in this right triangle, we apply Pythagoras theorem. So I'll call it Pythagoras because it was Pythagoras who discovered the theorem, not the society as his followers. The society uh, who followed Pythagoras was known as Pythagorean society. So it is not Pythagorean theorem. It should be Pythagoras theorem. So from this right triangle, hypotenuse square, BD square, equals BC square plus CD square. That's Pythagoras theorem. So BD is R square, then equals quantity 25 minus R square plus 15 square. So expanding 25 minus R square, it is the square of the first, twice the product of the terms of this binomial. So 2 times 25 times negative R, negative 50R, then square of the second term. So R square equals 25 square minus 50R plus R square plus 15 square. So we can cancel R square, and by additive inverse, negative 50R will now be positive 50R to the left of the equation. 25 square is 625, 15 square is 625, 15 square is 225, so it should be 850. So 50R equals 850. 850 divided by 50 is 17. So the radius is 17 meters. So from there we can solve for the area, but I will not present the solution for the area of the circle first. Let's have another way of computing the radius of this circle. Next is we extend AC to the other end as our second solution, and take note this is the diameter of the circle. Now if we connect D and E, the angle between AD and DE, or in other words, angle ADE is an inscribed angle subtending this arc, which is occupying 180 degrees because this is the diameter of the circle, and this arc subtends an angle here at the center equal to 180 degrees, or by definition or property in geometry, the inscribed angle, which is ADE, is always one half the measure of the subtended arc. Because the subtended arc has a measure of 180 degrees, then angle ADE is 90 degrees as shown. Therefore, because ADE is a right triangle, if we call this angle theta, then this angle here, because ACD is a right triangle, then this angle here, ADC, is 90 degrees minus theta. And since this is 90 degrees, therefore this angle here, CDE, is also theta. So we have similar triangles, the triangles ACD and the triangle ECD. So we define tangent theta in the bigger triangle ACD and tangent theta in the smaller triangle ECD. So tangent theta is 15 over 25 and tangent theta equals CE over 15. So 15 over 25 in this big triangle ACD is equal to CE over adjacent 15 in this smaller triangle, which is similar to ACD. So from here, we can solve for CE. 15 times 15 over 25, or 15 square over 25, and we find CE equals 9 meters. Having found CE equals 9 meters, and noting that AE is the diameter of the circle, so AC 25 plus CE 9 equals the diameter, which is 2R. So again, AC plus CE equals the diameter. AC is 25, CE is 9, equals 2R. So from there, 34 divided by 2, R is 17 meters. So next is the third way. After we find that triangle ADE is a right triangle with AE as the hypotenuse, so this is the hypotenuse, which is 2R, and CE is equal to 2R, the diameter, minus 25. So this is 2R minus 25 for the third solution. And because this is a right triangle, then in this right triangle ADE, AD square plus DE square, applying Pythagoras theorem again, equals diameter AE square, where AD is equal to 25 square plus 15 square, while DE, the hypotenuse of this triangle, is equal to 2R minus 25 quantity square plus 15 square, and it is equal to AE, which is the diameter, 2R quantity square. So again, AD quantity square plus DE quantity square equals AE quantity square, where AD square is equal to, in this triangle ACD, 25 square plus 15 square. Then DE square is quantity 2R minus 25 square plus 15 square, then equals AE, which is the diameter, 2R square. So by our experience with the calculations here, 25 square plus 15 square is 850. Then expanding this, 4R square minus 100R, 2 times negative 25 is negative 50 times so negative 100R, plus 25 square plus 15 square equals 4R square. So we can cancel 4R square. Then 25 square plus 15 square is also 850. So 2 times 850 minus 100, R equals 0. 1700 equals 100R. So R is 1700 over 100. R is 17 meters. For our fourth and final solution, you may have another solution here, but I'll just uh, limit it to this last solutions, last way. I'll use the theorem on intersecting chords. That is, the product of the segments of one chord is equal to the product of the segments of the other chord. So if we have here a circle and these are the intersecting chords, that theorem states that A times B equals C times D. So the proof of that theorem shall be discussed if I have given the time to present the theory lecture on plane geometry. Definitely, if I still have time and I'm still alive, as long as I have time, I will do that. But anyway, just accept the fact that although I'm uploading videos almost every day, then I'm planning to make the videos complete for a particular subject or course so that uh, students who would want to become engineers in the future will have a guide and a channel that has contents more than enough for you to master if you really stick on this channel. So AB equals CD, but I'm not saying that my channel is the best. It just happens that it has so many videos for you to refer to. And I hope that it can develop your mathematical skills. So this channel will upload videos that are important as your foundation to your chosen engineering field of specialization later. So AB equals CD, then try to imagine that right triangle ADE is being reflected about this line, the diameter AE. So we have now D prime. If that is 15 meters, this is also 15 meters because uh, ADE is mirrored about AE, which is the diameter. So in other words, if we connect AD prime, that's also equal to AD. DE prime is equal to DE as shown. So that's also 15 meters. And I hope it is clear here. So we have intersecting chords AC and CE and DC CD prime as chord. So by this principle, this is the first segment AC and this is the second segment of one chord CE. So AC times CE equals CD times CD prime. Since CD and CD prime are equal to 15 meters and AC is 25 meters, from there we can determine CE, which is 15 square over 25, just like this. So CE is 25 meters. CE is 9 meters. Now that we have found CE, which is 9 meters, again, 25 plus 9 is AE, which is the diameter of the circle. So we equate 2R minus 25 because this is the diameter 2R minus 25 CE equals 9. So 9 plus 25, 34 divided by 2, 17. So 2R equals 34, so R equals 17 meters. So finally, area of circle is pi times R square, pi times 17 square area, and 17 square is 289. The area therefore is 289 pi square meters. So that's it, and I hope that you were able to follow, especially those who are already graduates of engineering, and you can relate with these solutions. In fact, you encounter this also in your review with mathematics or even in your subjects in mathematics subject in engineering.